I first started talking to Red Paddle when I was really interested in how can we build a much bigger library of underwater recordings. So we listen to the health of the ocean. We put hydrophones into the ocean all around the world, and we can understand whether that environment is healthy. We can hear the animals in that world, but we're limited by where we can get to with our equipment. And what we were really thinking about was, with this enormous army of paddleboarders around the world, could we actually be using a paddleboard as a science platform? So we explored those ideas, and it was really exciting then to hear much more about what Red Paddle were doing, some of the real environmental concerns and challenges that they were trying to address. But one of those came down to the actual process of paddleboarding. When you go paddleboarding, you're experiencing the natural world, but you're also interacting with it and possibly interfering with it. So we were really interested in what do animals experience when you go paddleboarding around them. And one of the things that we've done a lot of work on is how noise pollution can affect animals underwater.
One of the interesting things about the way that sound works underwater is that it's really dependent on the environment that you're in. So if you're out in the open ocean, there's nothing there, it's sort of reasonably simple for us to understand how the sound is going to propagate through the water. In an enclosed freshwater environment, it gets really complicated. So I took some recordings in the River Exe in the middle of Exeter with stone walls on either side, and the sound will reflect off of those hard surfaces. And the sediment of the bottom of the water body makes a big difference too, because if that's solid, the water will reflect back up, or if it's muddy, the sound will be absorbed. So it was really important, first off, to work at a range of different sites so I could test how that affected the noise. And then I used, as Steve had alluded to before, a combination of equipment, hydrophones to measure the sound pressure, which is how humans hear, and also an accelerometer to measure the particle motion, which is how most fish and crustaceans hear. And that's the actual vibration of the molecules in the water. And then I paddled past my recording rig a bunch of times to make sure that I had a reliable sample size and that I wasn't looking at sort of erroneously high recordings at any point, to get a sort of solid understanding for what the noise actually is like on a regular basis. So for our crustacean study, we were looking at impacts like feeding behavior, presence, interactions between individuals, including aggression as well. So with the paddleboarder coming over the top, we were looking at whether the noise scared the crabs away and they stopped feeding, which would obviously impact the amount of feeding that they do in the wild if paddleboarders are present on a regular basis. Whether more or fewer crabs came to the bait at all if paddleboarders were around, and also whether there was aggression or competition for that food, and whether that was impacted by paddleboarding too. And what we found was that there were no clear impacts on any of those behaviors, whether paddleboarders were present or not.
I'm Dr. Sophie Nedelec, a researcher at the University of Exeter, and this year I've been working with Red Paddle Co. to look at the sounds of recreational craft underwater. Now, the sound underwater is really different depending on the environment around you, and the way that you can relate to this is that if you think about how my voice might sound out here in the natural environment versus in a small room with lots of soft furnishings, or even compared with in an echoey church, that you would know something just from hearing my voice about the surroundings that I was in. And it's just the same underwater for the animals that are hearing the sound from different craft that are passing through. So we took realistic recordings in these different environments But what we really wanted to know is what's the actual sound of the craft, and we call that the source level. And if we want to know the source level without the influences of all those echoes, then we need to make some recordings in deeper water. Now, the International Standards Organization writes standards on how things should be measured, like how long is a meter or that kind of thing. And they've written a standard on how to measure ship noise. But that standard involves going out to sea to really deep water, to the kind of places that we couldn't take a paddleboard. So we worked with the National Physics Laboratory, and they adapted that international standard to look at recreational craft like paddleboards and how we might record a source level or the sound signature of those types of crafts, but in shallower water. When policymakers are trying to regulate the amount of noise that can be made underwater in order to avoid disturbing any wildlife, then they need to know what kind of sound levels animals might be exposed to. So using that source level to predict what the sound level might be in any habitat will help policymakers to regulate the kinds of recreational activities that people can do. With some of our recordings, we found out that if people paddle slower, they make less noise. And that's really useful because we know that people can experience the natural world and enjoy paddling around with wildlife without disturbing it as much.